Hello there. Today we're going to talk about consolidating signs and numbers with signed unit and operations with signed numbers. And this is of course part of our signed numbers unit. So what happens when we have multiple signs? We have to deal with them somehow and get us to a position where we can solve our questions more easily. Let's get started. Let's also adjust the camera a little bit here. Alright, so first things first, it's about consolidating signs. So how do we deal with multiple signs in an arithmetic question? If there are multiple signs in front of a number, we need to somehow reduce the total number of signs to make the operation easier. So what we say is we can have a maximum of one addition or subtraction sign in addition to one multiplication or division sign, right? So I've got some examples on the slide here of some situations where we might have to do this. So in the first example, we have 10 plus minus 8 minus minus 4 minus 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 3. So what we do is we consolidate these three groups of signs separately and we somehow come up with only one sign, right? We don't have any multiplication or division in this top example here, so we're only going to have one sign where this blue circle is, one sign where this blue circle is, and one sign where this blue circle is. And we're going to talk about how to do that in the following slide. 2 slides from now, we're also going to talk about how we solve something like this. So what we do is we actually simultaneously consolidate all of these negative signs, and we come up with one overall sign, be it positive or negative. So let's go over how we do that. Okay, so in addition or subtraction, what we do is we consult all adjacent signs separately. Actually, we consult all adjacent signs simultaneously. So let's quickly just change that. We don't consult all the adjacent signs separately. We consult all the adjacent signs together, right? Let me just quickly fix that. Okay, and we're gonna from current slide. Exactly. So what we do is we look only at the negative signs and we cross out any pair of negative signs because a pair of negative signs makes a positive and that's not going to be useful for us anyway, right? Once we have more negatives than positives overall, we say that the answer itself is negative. So I mean, I know this is a whole bunch of information for you, and not all of it all might not make sense, but I'm sure some of these operations do look familiar. So before I tell you how exactly we're going to apply this technique to solve these questions, I do want you to give it a shot on your own. So I'm going to give you 5 minutes, and I have 3 questions here on the slide, and I would like you to try them independently, and we will take them up together at the end of the 5 minutes. See you in 5. 2 minutes to go. Okay, so time is up. Let's go back. I don't want to start this here. Okay, so time's up. Let's go ahead and take these up. So first off here we have 5 minus 4, minus 3, plus minus 2. So again, the first step is to only consider the negative signs, right? We only look at the negative signs because the positive signs, no matter what, give us a positive answer anyway. And so in looking at the negative signs here, we have these three groups, right? I'm going to use a different color just to show you the groups here. So we have this group, we have this group, and we have this group, right? And we're going to end up having one sign for each of these three groups, right? So what is the sign we're going to have in this group? Well, we have two negatives, remember? And when we have two negatives, we can cross them out, and this gives us an overall positive sign, right? Over here, we have three negatives. So these two negatives, you can think about crossing them off, but then we're still left over with this negative sign right here. And then same idea here. Here we have two negatives, so we can cross them out, and we have positive, positive, and then the other two we can consider them as positive as well. So this amalgamates to be a positive sign. And even here, you can think about crossing off these two negative signs and giving us a positive right there. So now we can just go ahead and use our original color and fill in the actual numbers. So I have 5, 4, 3, and 2. 5 plus 4 is equal to 9. 9 minus 3 is equal to 6. And 6 plus 2 is equal to 8. So this is equal to 8. And that is our final answer. Okay, we can quickly recheck that. Negative 3 plus 2 is going to give us negative 1. 5 plus 4 is 9. 9 minus 1 is also equal to 8. Same answer. Okay. So we're going to continue using this. We're going to actually switch over now to this red color here. And what I'm going to do is I'm going to use this red color again to isolate these adjacent groups. So we have one group here, and we have one group here. And again, we can use the same crossing off principle. So these two give us a positive. These two give us a positive, and a positive give us, of course, an overall positive. Over here, we have these two, which give us a positive. And again, we have positive, 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 which give us, again, an overall positive, right? And again, we can just fill in the numbers we were working with originally. I can go back to my blue color for that. So I have 8 plus 6 plus 4. 6 plus 4 is 10. 10 plus 8 is equal to an overall answer of 18. So what's really cool is in our original answer. If you just kind of rewind the video, you can see that we actually had a whole bunch of negative signs. We had a negative here. We had one here, we had one here, we had one here, we had one here, we had one here. So we had all these negatives, but somehow our answer ended up being nice and positive. So it's a good thing to learn how to consolidate these signs, because sometimes your answer is unexpected, and that's just a part of math, right? And so the last one, I'm going to use here the orange color to denote our adjacent circles. We have one over here, one right here. And crossing off, we have a cross there, which gives us an overall negative here with one negative left over, a negative here with one negative left over, and then over here, this ends up being a positive, so a positive and another positive give us an overall positive, actually, right? That looks kind of bad. So we have 2. Oops, I'm going to go back to that original red color here for you. We have 2 minus 3 minus of 8 and plus 5. Again, we can go ahead and work out the numbers here. 2 minus 3 is equal to 5. 5, I'm going to jump to this 5, so 5 plus 5 is equal to 0. 0 minus 8 gives us an answer of negative 8. Okay? And that is how you solve this. We're now done our 3 questions that I asked you to do. So hopefully you got the same answers, and if you didn't, now hopefully you know how to do those questions yourself. All right. So now we're going to move forward to consolidation in multiplication and division. So what we do is we treat the entire question, before we had those groups that we made, right? Between the 2 adjacent numbers, you would make a whole and a whole and a whole. We don't have to do that anymore. Now we treat the entire question as a whole and decide on whether the answer is positive or negative at the very beginning, right? If the entire question has positive or negative, if the entire multiplication or division question has an even number of negative signs, the answer is positive. Again, because a negative and a negative make a positive, and no matter how many negative times we repeat that, as long as it's an even number of negative signs, we end up with a positive answer. So negative negative is positive, negative negative is positive, negative negative is positive, and we can keep doing this, right? As many times as we want. The only thing is that both of the signs have to cross out, so that's what gives us the positive sign at the end of the day. Similarly, if the entire multiplication or division question has an odd number of negative signs, we consider the entire answer at the end of the day to be negative. And then again, once you decide whether you have a positive or a negative answer, you just ignore all the signs in the question and continue working through the question as if there was no negative sign to begin with. Okay? Now again, I know this is a whole bunch of information, and of course we will do the exercise and take it up, but before we do all that, I want you to give it a shot on your own. Okay, just like the last section. So once again, I have here a 5-minute timer. Just take a crack. There's no wrong answers, and once you are done, we will take it up together. All right? Once again, see you in 5. Okay, so time is up, and let's take this up now. So, once again, we're going to be deciding on one sign for the whole question at the beginning of every question. So let's go ahead and do that. So right for this question right here, we've got a negative here. So this is one of our pairs, right? And a negative here. This is two negatives, which is even. And what that means is that our answer is going to be positive. Right? And of course, 2 times 4 is equal to 8, so we go ahead and write that as our final answer. Easy peasy. Now, you can also think of this like we did the previous unit, right? So you can think of it as, okay, instead of saying that, hey, there's two negatives and we have an even value, you can simply cross out these negatives, and then we have also a positive number. So it's the same theory behind it. It's just a different way of thinking about it's either the adjacent bubbles that we made in the previous section, or in this case, it's all of them together. So whichever way you understand better, it's really up to you, right? Let's do the next question there, the blue one. We have negative 8 divided by negative 2 times negative 4 divided by 2. So again, I'm going to do it the old way this time. So we have negative, negative, that crosses out. So we only have one negative left over here. So we have one negative, which is odd. Right? Now notice that if you didn't do it this way, we would actually have 3 negatives, which is still odd, right? Because you would just cross out the negative one, the two of the negatives together. So same idea, which we know is negative. Right? Now just solving this question simply, 8 divided by 2 times 4 divided by 2. 4 divided by 2 divided by 2 just gives us 1. So the final answer is going to be 8. We decided over here that the 8 would be negative, so this will be negative 8. I'm going to put that in a bit of a box so you can see it better. And I'm also going to go back in the first question and put our final answer in a bit of a box so you can see it a bit better. There we go. Okay? The last question down there, the red one, we have negative 2 times negative 4 times negative 6. This bracket thing, whenever we have this kind of thing going on, all this means is that it's a multiplication question. That's it. Okay? So basically, again, we can do the same thing. I'm going to go back to this even odd way that we were talking about earlier. So I'm going to go ahead and use this new technique. So we have one negative here, one over here, one over here. Remember, we're now considering the entire question as a whole. So negative, negative, negative means our answer is going to be negative. 2 times 4 is equal to 8. 8 times 6 is equal to 48. So it's negative 48. And I can give it my nice little box here as well. There you go. Those are the three answers that I was looking for. Okay? Now, obviously, if you have a calculator kicking around, you can also check these answers, and you will hopefully get the exact same answer that I got. All right? Okay. So now we'll talk about, the arithmetic is done, but now there are some challenging combined problems in which there's questions that involve multiple operations at once. So all together with division, multiplication, addition, and subtraction. Now how do we deal with that? Okay, so the first one is this one that I call in purple fractions with operations. Basically, my hint for you here is to do the numerator separately, the denominator separately, and then you divide them. Okay? So let's go over how exactly all that is going to work. Okay? So let me just come up with a random question as an example for you. Let's go with, I'm going to use this yellowy color. So we're going to say, what if we had 2 minus 4 over, let's go with 8 minus 2, right? So if we had this kind of a question, first evaluate the top and evaluate the bottom separately. 2 minus 4 is equal to negative 2. 8 minus 2 is equal to 6. So negative 2 over 6. And then you can just divide the top and bottom. So in this case, this goes by 3. So this is equal to negative 1/3. Okay? No big deal. Sometimes you might get extra negatives, extra things involved. But of course, do the top first, then do the bottom, and then you simply divide. Easy peasy. Exponents, they're just a series of multiplication questions stuck together. So for example, if I had negative 2 to the power of 4, that is a very bad 4. We would do negative 2 times negative 2 times negative 2 times negative 2. And then we do this the exact same way. So you can do this the crossing off method, where we have a negative here. Let's do this in a different color so you can see it a little bit better. A negative here, a negative here, a negative here, and a negative here, which gives us a positive answer. And we know 2 times 2 is equal to 4. 2 to the power of 4 is equal to 16 because 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So the answer is going to be positive 16. Okay? Pop it in a bit of a box there. And we can put our old answer in a box as well. That way you can see it much better. There we go. Now, equivalently, we have to be a bit careful because let's say we had only negative 2 to the power of 3. This is negative 2 times negative 2 times negative 2, right? I've chosen not to make the brackets just to show this to you a bit better. In this case, we go ahead, we cross out the two signs that are the same negative sign. 2 times 2 times 2 gives us an answer of 8, but in this case, we get rid of only 2 of the signs. So we're actually left with an answer of negative 8. Right? Because this sign is left over. It's still a negative sign that's there. We still have to account for it in our final answer. So you've got to be careful when you're working with exponents. But it's the same general idea that we've been applying this entire video lesson. Okay? Now, the final one I want to talk about is a bit tricky. It's dividing with decimals. So basically, when you're dividing with decimals, you have 3 parts to the question. You have the divisor on the left-hand side. You have let me see if I can get a laser pointer out here. A divisor on the left-hand side, a dividend right here in the middle. This is underneath the division, like little hat thing, underneath the division sign. And then the quotient, we're not going to deal with the quotient today really that much. It's our final answer, right? So here's my 3-step procedure. Number 1, move the decimal over until the divisor, so this blue guy here, no longer has a decimal. And then you move the decimal over in the dividend the same number of times. And at the very end, you calculate. And then I'm going to show you how the decimal is going to do this thing called moving up. Now, how does all of this work? Of course, we'll go over it, but I do want you to take a crack at this on your own. You likely know how to do this from previous classes, from drills and stuff like that. So I would like you to try this on your own. Again, we have a 5-minute timer ready to go. So go ahead, take a crack at it, and once again, I will see you in 5 minutes. Alright, so time is up. Let's go ahead and solve this problem. So the first step here is to move the decimal over until the divisor no longer has a decimal. So you just take the decimal and you move it right over there. The second step is to move the decimal over in the dividend, so the part underneath the circle there, the same number of times. So we moved it over one time in the divisor, and it moves over one time in the dividend. So now we actually have a whole new problem to work with, which is 47 dividing into 1234.56. And this is the problem we're going to work through together. They're the exact same problem, it's just the second one is much easier to solve when compared to the first one. Okay? So, first of all, 47 doesn't go into 12. 47 goes into 123 twice. 47 times 2 is equal to 94. And then 123 minus 94, I'm going to quickly check that. That is equal to 29. Whoops. Oops, we're not done yet. Just a second here. We bring the 4 down, so this becomes a 294. And then how many times is 47 going to 294? 7 looks like it's going to be 7 times 47 is a lot more. That's way more than 280, probably even more than 290. So I'm going to play it safe. I'm going to go with 6. 7 times 6 is equal to 2, carry the 4. And then 6 times 4 is 24, 25 from 6, 27, 28. Yeah, that looks like it's going to work. If we subtract them, we get now to 12. Perfect. Right? At this point, you can see we've done division normally. And then all you do is that now the decimal in the dividend, which is still left over here, we simply write it right on top. That's it. And now you just keep going the same way. Just ignore the decimal altogether. So now the 5 comes down. Right? Again, I think 3 is going to be too much. We're going to go back to 2. 27 times 2 we've already calculated is equal to 94. The subtraction there gives us 31. If we bring the 6 down, we get 316. Right? Again, 316, this is going to go 6 times to give us back that amazing 282 number. So I'm going to continue this over here, which is 316. And then we get 282. And you subtract this. We brought down our last number already, so the answer is simply 35. And that is our remainder. Right? We don't work with remainders too much in this course. We do at other times, but it's good to know that the 35 is actually there. So we can say that the remainder is equal to 35. So this is also something we can put into our little family of questions in a division question. Right? And this is the correct answer. 26.26 is the right answer. And that is how you can divide decimals without using a calculator. As I said in the previous video, we need to work on both our calculator skills and our non-calculator skills. So this is an excellent way of going ahead and doing that. Okay? All right. I did want to mention one final thing before we dismiss for today's video. I am not covering today the relocation property. So any questions involving relocation, I do want to first spend a whole unit on relocation first, and then we can go back and do those questions later. So if you find a question that involves relocation, or if it gets a bit too much to just do in your head directly, don't worry too much about it. Don't sweat it. We will go back and we will do those questions after we finish that unit. Other than that, have a fantastic week. Take care, stay safe, and I will see you in the next video. Bye-bye for now.